Okay, so let's look at the cons that you're going to do for homework tonight. So first one, analyze concavity graphical. So let's look and see what this means. Select all the intervals, so maybe more than one apply. When I did this the first time, I had one problem where I think there was only one answer, another problem where all three of them were correct, and then another one where it was none of the above. So don't feel like you're doing it wrong if you get any combination of answers. G prime less than 0, what does that mean? G prime less than 0 means that G is decreasing. So this is a graph of G. I want to find where G is decreasing, going down. So there's a lot of places where G is decreasing, right? Or a couple. G double prime less than 0 means that G is concave down. So opening down. So I want to look only at decreasing and opening down. So here it's opening down and decreasing. So somewhere around -4, oh, look at that, -4, and then all the way to -3, it is decreasing and concave down, okay? And then somewhere around here, it changes to concave up. I can't identify a point of inflection simply by looking at a graph, but I can say it's somewhere around -3. Okay, I would need the function to identify a point of inflection. So here's where it's concave up, and that's not what the question is asking. The question is asking for concave down. So somewhere around here, it changes to concave down, okay? But in this interval, it's increasing. And again, that's not what the question is asking. So somewhere around 1, maybe a little bit past 1, it's decreasing, right? And concave down. Oh, look, 1.5 to 2, that one works also. 1.5 to 2 is decreasing and concave down. 2 to 3, yeah, that looks like it's still decreasing and concave down. The point of inflection would be somewhere in this interval, but they're not going to be so tricky that they're going to say it's like 2.9 or something like that. So I'm assuming that they're being nice and the point of inflection is somewhere over here. Let's see if my assumption is correct. Woohoo! Okay. What is this one? Okay, so this one says G prime is less than 0, so decreasing just like the last one, but G double prime greater than 0 now means concave up. So I got to remember decreasing and concave up. So going down from left to right and opening up. Decreasing and concave up, that looks like it's decreasing and concave up all the way until somewhere around there. So yeah, it's at -4, it's decreasing and concave up, and sure, it goes to -2, yeah, for sure. Oops, I didn't mean to click that. I meant to point to the -2. From -1 to 1, it's concave up, but it's increasing, so that's not going to work. And then from 3 to 4, it's decreasing, but it's concave down. And remember, we want concave up. So it's only that. Yay for me. And then last one. Increasing and concave down. So let's just look at the intervals. -4 to -2. -4 looks like it's increasing and concave up. I want concave down, so that's not going to work. -2 to 0, definitely increasing, yeah. And concave down, opening down, so that's going to work. And then 0 to 2 is decreasing, so that doesn't fit that. So we didn't get a none of the above on this one. Don't freak out if you get a none of the above, please. There is, I got a none of the above previously. Okay, so we've got that, and then the other one is that. So this is the similar, it's just not giving me a visual. So I'm going to use the scratch pad, and y'all can laugh at me because you know my drawings are going to be awful. F of 2 is 3, so whoa, 2 comma 3. Let's say this is 2 comma 3 right here. Okay, I'm just estimating. I'm just trying to get a visual. F prime is equal to 0 when x equals 2. That means there is a horizontal tangent, right? The derivative is 0 means the slope of the tangent line is 0, okay? If double prime is positive, well, positive means concave up. Whoa, whoa, concave up, right? So what does that mean is happening right at x equals 2? At x equals 2, or that 2 comma 3 point, there is a minimum point. Okay, that's the second derivative test. Second, it sounds all complicated and scary, but it's actually just draw a picture and it totally makes sense. Okay, yay. -3, 4. So let me draw a picture. I mean -3, -4. Okay, so let's say -3, -4, somewhere around here. I've got a point. And the first derivative is 0. Again, first derivative is 0 means there's a horizontal tangent. First derivative is positive means concave up. Is this exactly the same as the one we just did? I think it is. Second derivative is positive. Means the function is concave up. So again, at that point, -3, -4, there is a minimum. Hopefully we get a different one on this last one. -1, 4. I think my lines are getting straighter the more I do this. Haha, not so much. -1, 4, right here. Something like that. Again, first derivative is 0. That's what the second derivative test says. If the, it's exactly the same. First derivative is 0 means there's a horizontal tangent. Second derivative is positive. So all of these are referencing when x equals -1. Okay, we're talking about all the same x value. Second derivative is positive means I am concave up, which means I have a minimum point. So just because we didn't see it, let me show you what the other one would be. Let's just say I have some random point. Okay, you can see where I'm writing over here. Let's say the first derivative is 0, and the second derivative, let's pretend, is negative. The second derivative is negative means the graph is concave down at that point, so then this would be a maximum. Okay, just in case you come across it. But I'm sure you figured that out. All right, have fun.